All right, guys. So welcome back, everyone. So this is lesson number 2. This is lesson number 2 for your Form 4 chemistry. Yeah. So first and foremost, let's do a very quick recap. Let's do a very quick recap, about 5 to 10 minutes. What we learned, what we covered in the past lesson. So in the last lesson, we learned we learned what is matter. Yeah, we learned something about matter. So matter is referred to something that has mass and also occupied space. Okay, that is matter. So all the matter they make from smaller thing, we call smaller particles. All the matter, they are made by some smaller particle. Example, house is made by smaller particles. Okay, let's say human, we are made by smaller particle like cell. Yeah, a house, the smaller particle is bricks, something like that. Yeah. So all the matter they make by something smaller, which we call particles. So there are 3 particles we need to know in chemistry, which is atom, molecule, and ion. So make sure everyone know the differences between atom, molecules, and ion. Atom is somebody who come alone. So if the substance come alone, they didn't have friend, they don't combine with anything, so they are atom. Example, carbon come alone, it didn't combine with anything, so it's an atom. Aluminium come alone, it didn't combine with anything else, so it's an atom. So molecule is non-metal and non-metal joined together. So when you take some non-metal joining together, you got molecule. Example, water. Water is a molecule. Why? Water is made from hydrogen, which is a non-metal. Water also made of the oxygen. Oxygen also a non-metal. Non-metal combined together, you form molecule. Okay, what is ion? Ion is somebody who carry the charge or anything made from metal and non-metal. So when you got charge, you are ion. When you have metal and non-metal combined together, they are ion. Example, Cl minus, this fella got charge. It is an ion. Na plus, this fella got charge, is an ion. Let's say MgO, magnesium oxide. Although I didn't see any charges there, I didn't see any charges over here, but magnesium is a metal, oxygen is a non-metal. So when metal and non-metal combine together, this fella is an ion. So that's what we learned in the previous lesson. Okay, what else we learned in the previous lesson? In the last lesson, I also introduced you all what is element, what is compound, and what is mixture. I hope everyone still remember. Element is something made from one species. When you only have one type, one species, it is an element. Example, zinc, there's only one type of substance, that only Zn, nothing else, so it's element. Oxygen gas, O2. So although you have 2 oxygen out there, but all of them, they are same species. They are all oxygen. So you only have one species. So it's an element. So compound is combination of more than one species. Okay, when you have 2 species, 3 species, 4 species or more, combined together is compound. Example, carbon dioxide is a compound. Why? Carbon is one species, oxygen is another species. So in this question, we have 2 species. So it is compound. So what is mixture? Mixture means that they only mix. Okay, they didn't combine and form something new. They only mix together. They didn't combine and produce something new. Okay, and for mixture, they can be separated very, very easily. That's what we learn. Okay, okay. So what else we learn? We also learn change of state, right? We also learn solid versus liquid versus gas. So do remember how you draw solid in SPM, minimum 3 times 3, minimum 3 times 3. And then the whole box must be fully occupied. Liquid, you draw a smaller gang of 4 to 6 or 4 to 8. You draw a few gang like this. Gas, they must be far apart. Not necessary 1, 1, and 1. it can be 2, it can be 3, no problem one. As long as they are far apart, then they are gases. Yeah. So we also learn how to convert from one state to the other. Quick revision. Solid converted to liquid. This process called melting. Okay. Liquid converted to gas. This process can call boiling. Also can call evaporation. And I told you all what's the difference between boiling and evaporation. Can we do a quick revision again? We mentioned this last lesson. Anyone can tell me, volunteer. There are 2 differences between boiling and evaporation. Can anyone type in the chat box and let me know? We discussed about this in the last lesson. Can anyone, type in the chat box to remind everyone? Okay, good. Okay, the first answer I can see. Okay, let's say, all right, good. Okay, I see 2. Okay, boiling only occur at boiling point. Correct. Boiling only occur at boiling point. Meanwhile, evaporation happens at any temperature. Evaporation can happen at any temperature. Boiling only happen on boiling point. Okay. Second thing, evaporation only occur at the liquid surface. Boiling take place in the entire liquid. Boiling, the whole liquid, top, bottom, left, right, the whole liquid boil. But evaporation only involve the surface. Okay, so this is what we covered last lesson, isn't it? Okay, then go terbalik. Gas go back to liquid, condensation. Liquid go back to solid, freezing. Okay, then be careful. Solid go to gas directly without going through liquid, sublimation. Gas go back to solid. Gas becomes solid directly without going through liquid. This is deposition. So all these things is something we learned in the last lesson. I hope you still remember. Again, if today is your first lesson, today if you just join the class, this is your first lesson, maybe you'll feel a bit blur. No worry, you will be fine. If let's say you miss out any lessons, please watch back the recording. For example, if you just joined the class today, please watch back the recording for last lesson. Yeah, all right. So, and when you watch the recording, if there is anything you're not sure, feel free to ask me. Don't be shy, don't be embarrassed. Just ask me. I'm here to help you. Yeah, all right. So now, okay, I also told you how to remember the process need to absorb heat or release it. How to know which process the heat is being absorbed, which process the heat is being released. I teach you a simple way to remember, right? When you want to break up, okay, when you want to break up, you want to absorb the heat. Example, solid want to be liquid. So solid sticking together. When you want to be liquid like this, you need to break it. So when you want to break up, you need to absorb heat like this. These are 2 person, okay, they're holding their hand. When you want them to break up, they need to absorb the heat. Why they want to absorb the heat? Because they break up because they don't like each other. Okay, they are angry. So how to become angry? Absorb the heat, make you become angry. Absorb the heat, become angry. You angry, I angry, we broke up. Okay, so how they become angry? They absorb the heat. Yeah, same thing. All right. So when they want to join together or when they want to stick together, okay, so they need to release the heat. Example, I am a gas. I want to become liquid. How the gas can become liquid? Gas. If you want to become liquid, you need to stick together. So when you want to stick together, is something like this. This is a gas. This is a gas. So if you want to stick together again, you want to hold people hand. You want to hold people hand. So when you're holding people hand, so they will release energy. That's it. So remember, holding, joining together, release energy, break up, absorb energy. Okay, so that's it. Okay, what else we learned in the last lesson? The last thing we learned in the previous lesson is called 3 lines method. So what is 3 lines method, everyone? We draw 3 lines that can help us to predict we have a solid, we have a liquid, or we have a gas at a very specific temperature. Okay, so let's use one example for demonstration. Is okay? Let's do one example for quick revision, not demonstration. Quick revision. Then we move on. Okay, let's say you are given a substance. Okay, let's say this substance is called C. Substance C melting point is negative 18 degrees Celsius. Substance C, the boiling point, it is, let's say, the boiling point is, assuming, let's say, it's 4 degrees Celsius. Okay? So they ask you, what is the state of C at room temperature? Okay, for those who attend the class last week, I assume you should know how to do it. So let's do it together. First and foremost, everyone, room temperature, how much? Type in the chat box. We mentioned last week. Room temperature, how much it is? Very good. 25. Understand? Not 27, not 24, not 37. No, 25. Room temperature, always assuming 25. So how to predict the state? When you see the word state, which means the answer has to be a solid or a liquid or a gas. That's it. Okay. So now, to do this kind of question, we can use a 3 lines method. So 3 lines method, draw 3 lines. First line, second line, third line. Okay, so the first intersection here, the first intersection means this cross. The first intersection is your melting point. MP means melting point. The second intersection here is your boiling point. So your melting point, how much? Negative 18, given. Your boiling point, how much? 4, given. So the first box here is a solid. The second box here is a liquid. The third box here is a gas. Now, what temperature we wanted? We want room temperature. So remember, room temperature is referring to 25. So you just use common sense. Where is 25? 25 is here, negative 18. No, here should be negative 19, negative 20, negative 21, isn't it? So 21, 25 should be here. No, if this is 4, 3, 2, 1, 0, negative 1, negative 2. Yeah, 25 should be more than 4. 4, 5, 6, 7, 8, 9, 10, 25. So 25 should be somewhere here. So who are you? Yes. Okay. So I hope everyone still remember how to use the 3 lines method to predict whether you have a solid, a liquid, or a gas. Okay. So that's it. So you see, we spend the first 10 to 15 minutes learning nothing but doing revision. This is very important because if you don't do revision, sometimes you forgot what you learned already. Guys, can you please let me know in the chat box, how's everything after the revision? Are you okay? Okay or not? Right? Let me know in the chat box. Is it okay? Just a very quick recap. What we covered, what we learned in the past lesson. Yeah? So same thing, guys, like what I say, if this is your first lesson, maybe you are not okay. No problem. You'll be fine. Just watch the recording and you will be fine. You'll be able to catch up with us once you watch the recording. Okay, so guys, now, today, we will do 2 things. Yeah, today, there's only 2 things we should do. Number 1, I will discuss I'll discuss 1 question with you. Okay, then I'll teach you a new concept called heating curve and also cooling curve. I will teach you heating curve and also cooling curve. Yeah. So this is our main objective for today. So today's lesson will be more challenging compared to last week. Why? Last week I told you off, the first lesson is honeymoon lesson. Why? Because most of the concept we learned last week, actually, you learn back in your Form 1, Form 2, Form 3. So it's not very hard. But today, the heating curve and cooling curve that I'll teach you in a short while is something totally new. Something that you never learned in Form 1, never learned in Form 2, never learned in Form 3. So it's something totally new for you. Yeah? But no worry, you'll be fine. Okay? Anything not sure, just ask me directly. Okay, come. Let's do this question first. Okay, we do this question together. Okay, so guys, I told you all in the last lesson. When you come to learning, not only chemistry, other subjects is the same thing. When you come to a learning process, there's two important parts there. The first one is the theory. Theory means understanding. Okay, you need to understand the concept first. Then the second one is the problem solving. Okay, problem solving in the other word called answering technique. How to answer the question. Okay, so now the problem for majority of students, a lot of students, including Form 5, the problem is always here. Theory, they seems understand. They say, Mr. Martin, I think I know the theory. Okay, I think I understand the theory. But when I do questions, cannot, I cannot score. I cannot score. Okay, so that's the problem. A lot of students, their weakness is here. They don't know how to answer the question, answering techniques. That's why for me, my teaching style is what? After teach you all the theory, I will always go through some question with you. And when we do the question, I want you all to focus on good quality question. Okay? What do I mean by good quality question? I not encourage you all to do the question from reference book. Okay? I not encourage. I not encourage you all do the exercises in textbook. Of course, you can do it, but I not encourage it. Why? Reference book and textbook exercises, the standard not the same as SPM. They might be too easy or maybe too hard. Yeah, no point one. I heard a lot of story from my student that told me that, sir, I can do all the questions from the reference book. I couldn't do my SPM. A lot people like that. Yeah. So my advice, I won't say waste your time to do it, but I not encourage you to do it lah. If you really want to do the question, do trial exam paper. You can do it. And then you also can throw exam paper in BM called soalan percubaan, or you can do SPM past year paper. Okay, do this paper. They are much more helpful for you because at least the format they use follow the SPM format. Yeah. Okay, come. So anyway, let's look at here. Okay, so this question that I want to show you is a real trial exam paper. This is a trial exam paper from Johor in the year 2022. And I want you all to participate and go along with me. So guys, just try, no problem. No harm trying. Don't be afraid of making mistakes. It's okay. Making mistake, never mind one. Most importantly, you learn from it. It's okay. All right. So now you're given 5 substances, P, Q, R, S, T, and you're given their correspond melting point as well as their correspond boiling point. Tell me the name for one of the substance that exists as solid at room temperature. So who is solid at room temperature? So guys, can I give you a sweet maybe 2 to 3 minutes? You tell me from here, using the 3 lines method or whatever method you want to use, can you tell me among these 5 substances, who is solid at room temperature? Come on, take your time and try to do it for me. Yeah. I'll pause the recording for a while. Yeah. Okay, well done. Well done. I see a lot of students answer S and T, which is correct. Okay, it's S and T. Yeah, S and T is solid. Okay, why? Because simple thing. We draw a 3 lines method lah. Okay, simple thing. Remember, 3 line method, the first one, negative 101 and negative 35. This is substance P, Q, R, S, and T. Okay? So this is solid, liquid, and gas. So room temperature is 25. So where is 25? 25 is more than negative 35. So it's here. So this fella should be a gas at room temperature. Wrong? So look at the second one, the Q. Melting point negative 94, boiling point 65, solid, liquid, and gas. So you're looking for 25 degrees Celsius, room temperature. So where is 25? 25 is in the middle of negative 94 and 65. Is it in the middle? So in the middle, who are you? Liquid. Okay? So you know already this fella should be a liquid. Substance R, Same thing, 3 lines method. So you have 17.8 and then you have 290, solid, liquid, and gas. So now 25, where is 25? 25 is in the middle of 25 is more than 17.8, less than 290. So it's in the middle. Middle means liquid. Okay. So now look at substance S and substance T. Okay. Substance S and substance T. Substance S. Okay. Substance S. All right. Your melting point is 97.8. Your boiling point is 883. Solid, liquid, and gas. So room temperature is 25. So 25 is lesser than 97.8. Lesser. So here, solid. So yes, this fella is a solid at room temperature. Now let's look at the last one, substance T. Substance T, 3 lines method, 801 and 1413, solid, liquid, and gas. So now we know the room temperature that we wanted is 25. Where is 25? 25 is lesser than 801. So on the left-hand side is here, solid. So by right, who is solid? S and T. But if your answer is S and T, how many marks you will get? 0. Why? Okay, because you don't understand the instruction of the question. The question only asks name a substance, but you give 2 answers. Wrong. Cannot. Understand? Cannot. So what you should do here, of course, your answer is S and T, correct, but you only can answer one of them. Okay, so your answer must be S or T. Okay, only give one answer. So you really need to know the instruction of the question. They say a substance. Don't give 2 answers, please. Yeah, simple as that. You can answer S, you can answer T, no problem. Okay, next one. Okay, now this is a good question. Which substance will undergo freezing when they place in a refrigerator? When you put in a fridge, the temperature is 2 degrees Celsius. You think among 5 substances here, who will undergo freezing? Freezing means become solid. When you put in a fridge, the temperature is 2 degrees Celsius. Same thing, guys. I'll let you have a sweet 2 to 3 minutes. Try to do the question and type the answer in the chat box. This question is very interesting. I'll tell you in a short while why. Okay, let's continue. Okay, I can see so far in the chat box, majority of students answer Q. There's only one student answer R. Okay, let me tell you guys. Okay, let me be very honest with you guys. I'm actually quite sad. I'm actually quite sad to see answer Q actually. Because Q is one of the worst answer you can choose. Why? Okay, guys, again, not to offend any one of you and not to scold any one of you at all. Can you tell me why you choose Q? Why you choose Q? You see, all right, freezing. What freezing want to do? Freezing want to change liquid to solid. They want the freezing to occur at 2 degrees Celsius. Okay, I see so many people answer Q. And again, I don't know why you answer Q. Why? Let me tell you why the answer cannot be Q at all. Okay, let's draw a 3 lines method. Melting point, negative 94. Boiling point, 65. So, negative 94 is melting point. 65 is your boiling point. This is solid, this is liquid, and this is gas. Now we want to do freezing at 2 degrees Celsius. So what is the temperature we wanted? 2 degrees Celsius. Can anyone tell me where is the 2 degrees Celsius? 2 degrees Celsius, where are you? 2 degrees Celsius, are you here? No, this is negative 94, negative 95, negative 96, negative 97, Matronaut. All right? So, where is 2 degrees Celsius? 2 degrees Celsius is here or not? In the middle of negative 94 and 65. So, you suppose a liquid. So, when you are a liquid, do you freeze? No. Freezing must convert to solid. Okay, so guys, again, I'm not scolding any one of you. Can any one of you who answer Q, which I see a lot, Can anyone of you tell me why you answer Q? Can you tell me, please? Can you tell me why your answer is Q? Just let me know, because I'm quite curious. Because so many of you answer Q, there must be some concept that you are using. Can anyone tell me why you answer Q? I'm waiting for the answer in the chat box. Tell me why you answer Q just now. Hi guys, I see many people answer Q just now, right? Can you guys please let me know in the chat box why you answer Q just now? What's the reason? What's the reason? Like, what's the logic or what's your thought that let you think the answer is Q? Can you please let me know? Hey guys, no one. You, I mean, you answer Q for sure. That's the reason, okay? You can't tell me that also I don't know why I answered Q just now, right? Guys, anyone, please tell me why you answered Q just now. Okay, never mind. Okay, I'm very mad. Okay, you give the answer Q, but no one want to tell me why you answer the Q. Yeah, never mind. Yeah, all right. So, okay, guys, my question is that, okay, so guys, everyone, do you know why the answer is not Q? Let me know in the chat box. Are you okay? Why the answer is not Q? Okay, Q is a liquid, because at 2 degrees Celsius, so 2 degrees Celsius is in the middle of negative 94 and 65. So it is a liquid, but we are not looking for liquid, right? We want freezing. Sorry, freezing should be liquid to solid. Sorry, I write wrongly. This one should be solid. My bad. My bad. Should be solid. Freezing is liquid to solid. So obviously, 2 degrees Celsius, you are liquid, you are not solid. So cannot be. So that's why I say Q is one of the worst answer you can ever choose. Okay. So guys, now I tell you a common mistake for many students. Okay. Actually, some students get more than one answer. Some students get R, S, and T. Some students get 3 answer. Anyone get 3 answer one? R, S, and T. If you get 3 answer one, can you type 3 in the chat box? Any one of you? You get 3 answer one. R, S, and T. Any one of you? You found there are 3 answers one. Anyone? Okay, Daniel. Okay, who else? Who else found there are total 3 answers? Okay, Wan Yin also same. Okay, guys, let me tell you. Okay. Uh, The correct one actually is R only. No S and no T. Why? Okay. Let me tell you why a lot of students, they think there are 3 answers RSDC. For substance R, melting point 17.8, boiling point 290, 17.8 and 290. Okay. So this is a solid, this is a liquid, and this is a gas. So what temperature we wanted? 2 degrees Celsius, because you put in the fridge, and the question say the fridge is 2 degrees Celsius. The fridge is 2 degrees Celsius. The question mentioned that. Yeah, the question mentioned that. Okay, so now, where is 2 degrees Celsius? Here, throughout 2 is lesser than 17.8. So should be a solid, lah. Correct. So substance R should be a, this is R, S, and T. Substance R is a solid at 2 degrees Celsius. Looks good, sounds good. Look at substance S. Substance S, melting point 97.8, boiling point 883. So 97.8, 883. Solid, liquid, gas. Same thing. We want 2 degrees Celsius, right? 2 degrees Celsius. Where is it? By right, 2 degrees Celsius is less than 97.8. Yes, you should be a solid also at 2 degrees Celsius. Substance T, melting point 801, boiling point 1413. Okay, so melting point 801 and 1413. So this is solid, liquid, and gas. So what temperature we want? Now we put the thing in fridge. Fridge, the temperature is 2 degrees Celsius. Where is 2 degrees Celsius? Should be somewhere here, 2 degrees Celsius is lesser than 801. Should be solid, So you see, by right, it looks good. R, S, T, by right, all of them are solid at 2 degrees Celsius, right or not? The R, S, and T, they are solid at 2 degrees Celsius. Looks good. But how come the answer cannot be R, S, T? The answer is only R. If you answer S, is wrong. If you answer T, is wrong. Why? Okay, because of this. First of all, everyone must know what is freezing. Freezing must convert the substance from liquid to solid. Okay, so what is the, which means originally, this substance must be a liquid. Okay, when I say original means what? 25 degrees Celsius. Okay, at room temperature, that is the most original condition. So at 25 degrees Celsius, they should be a liquid. They should freeze, become solid at 2 degrees Celsius. Why 2 degrees Celsius? Because the question say that. So now can we check among the 5 substances here, who is liquid at 25 degrees Celsius in the first place? So just now, we do it in the previous question, or not? The previous question just now, we did it. Okay? So substance P is gas at room temperature. Substance Q is liquid at room temperature. Substance R is liquid at room temperature. Substance S is solid at room temperature. Substance T is solid at room temperature. So we only looking at liquid. Okay, we only looking at liquid. So the answer may be Q and R. So then only we check. Okay, Q and R, they are liquid at the room temperature. Who is solid at 2 degrees Celsius? So the solid just now, if you figure out, like what I say, who is solid at 2 degrees Celsius? Substance R, S, and T. True or not? Substance R, S, and T is solid at 2 degrees Celsius. Do you see who is something in common? Substance R. Only substance R is possible. Okay, why the answer cannot be substance Q? Substance Q is liquid at 25 degrees Celsius, but when you put in fridge at 2 degrees Celsius, substance Q, where is it? Substance Q, negative 94 and 65. So where is 2 degrees Celsius? In the middle. So you are liquid. So which means what? Substance Q, when you put in fridge at 2 degrees Celsius, it is still a liquid. So you are liquid, you put in fridge, you still a liquid. Do you freeze? No. That's why substance R cannot be. Okay? Why the substance cannot be substance S and T? Now, why cannot be S and T? Substance S already a solid at room temperature. Guys, imagine this. If I already have one solid at room temperature, if you put solid in the fridge, do you think the solid will freeze again? No, freezing must convert liquid to become solid. But what's the problem with substance S and T? Substance S and T at room temperature, which is 25 degrees Celsius, they already solid. When you already solid, you put in the fridge, they cannot do freezing anymore. That's why the best answer is substance R, because substance R is a liquid at room temperature, and substance R is a solid at 2 degrees Celsius. So liquid change to solid, That is what freezing all about. Guys, let me know in the chat box, are you okay with how to do this question? Are you okay why the answer is substance R only, not others? Are you okay with this? This question looks easy, but trust me, out of 100 students, only one or maximum two students can answer this. Out of 100 students, only one or two students can get this one. All right? Looks easy, but not that. Because a lot of students were just thinking, oh, 2 degrees Celsius, draw 3 lines, 2 degrees Celsius, solid, 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 wrong. Yeah? Because this answer only tell you who is solid at 2 degrees Celsius. But to do freezing, we need to do one more thing. We need to check this substance who is liquid in the first place, who is liquid at 25 degrees Celsius, then convert, become solid at 2 degrees Celsius. Yeah? Okay, good. Okay, for those who are not replying, can you understand? For those who are not replying, can you understand? So guys, that's it. Don't be fearful, okay? Just try making mistake, never mind one, okay? So that's why, guys, just now I tell you, I'm quite upset just now because so many students answer Q. But when I ask why you answer Q, but no one can tell me one, then what's the logic? You answer Q, just simply put Q only, is it? Because when you write the Q as an answer, there must be your thinking, there must be a logic. Why you answer Q just now? But when I'm asking, not even a person willing to share with me why you choose answer Q just now. Okay, I'm 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 quite sad actually lah. Okay, I'm not really mad, but I'm very sad actually. Yeah, I'm very very sad. Yeah. Okay. Anyway, let's move on. Okay. So what is the change in the physical state in B1? Okay, B1, what happened? B1, freezing. So freezing, what happened? Freezing convert liquid to solid, isn't it? Freezing, freezing, what is the change in physical state? State means solid, liquid, and gas. Yeah. Okay. So freezing convert the liquid all the way to the solid. That's it. So this question is that's how it works. You see, that's the reason why we don't keep on moving forward, keep on going very fast to do the question, because you see, majority of you still cannot do this question, isn't it? Majority of the students still cannot get all 3 correct. So what's the point we keep going so fast since your answering technique is not there yet? Yeah. All right. Okay. So I hope everyone can answer. So I hope everyone can understand. So like what I say, if you don't know how to do, never mind one. It's okay one. Just try lah. Okay. So most importantly, you must know what is your mistakes and you improve from there. That's it. Okay. All right. So now we will go on and learn something new today. Yeah. Okay, so we will learn something new today, which is called heating curve. Heating and cooling curve. So heating and cooling curve is something very, very technical. Okay, heating and cooling curve is something very technical, which require a lot of skill. Okay, which require a lot of skill. Okay. So same thing, if you have anything not sure or don't understand, please ask lah, okay? Because again, if everyone keep quiet, I really don't know how to help you because I'm not a god. I don't know how you think if you never tell me. Yeah, all right. So what is heating curve and cooling curve? Okay, heating curve and cooling curve, they are actually a graph. Okay, they are actually a graph. What is this graph all about? This graph is temperature and time. So when you see there's a graph, the graph is temperature versus time, then you know this is heating curve or cooling curve. Yeah, temperature and time. Yeah. So I want you to know how the heating curve and cooling curve looks like. Yeah. Okay. Heating curve and cooling curve, the shape is this. They are staircase. So when you see staircase, you know that they are heating curve or cooling curve. Example, the staircase look like this. You see? Staircase. You got it? All right. So the staircase can go up, the staircase also can go down. So whenever you see staircase, you know already it is heating curve or it is cooling curve. Simple as that. Yeah. All right. So how to know it is heating curve or cooling curve? Common sense. When you do heating, heating curve. When you heat a substance, what happened to temperature? Temperature will increase, right? When you heat a substance, the substance become hot. So the temperature go up. So you will see the staircase is going up. Same thing. When you do a cooling curve, when you cool down a substance, cooling down a substance, temperature go down. That's why you see a staircase going down. You got it? So whenever you see staircase, you know it might be heating curve, it might be cooling curve. Okay? So heating curve is a staircase going up. Cooling curve is a staircase going down. All right? Simple as that lah. Okay. Now, okay, why we need to learn heating curve and cooling curve? Huh? We not learn this for fun. There is a reason why we need to do that. Okay, there's a reason why we need to do that. Okay, so heating curve and cooling curve help us to find those important temperature. Like they help us to find what is the melting point for a substance, what is the boiling point for a substance, what is the freezing point for a substance, and what is condensation point for a substance. Yeah, heating curve and cooling curve help you to find those important points: melting point, boiling point, freezing point, condensation point. Sir, what about sublimation and deposition? No, they want us sublimation and deposition for heating curve and cooling curve. Huh? Okay, now I would like you all try this question. Let's say this here SPM, let's say this here SPM asks you all, what is melting point? What would be your answer? If this year SPM asks you, oh, what is melting point? Okay, what you will write for your answer? Come on, try this. Okay, I'll give you some time. Try this. If this year SPM asks you, what is melting point? What you all will write as the answer? Just try. Just try. Okay, I get quite a few, good answers in the chat box. Okay, all right. But again, not much can get full mark so far. Um, so far, so far, so far, no one. So far, no one can get full marks. So far, based on the answer you wrote. So far, no, not even a person can get full marks. Okay, guys. Now, let me tell you a common mistake for many students. Okay. One of the common mistakes for a lot of students for this. What is melting point? Okay. So melting point is a point where solid change to liquid. So this is one of the very common answer given by quite a number of students. But I'm quite surprised to see that so far in chat box, there's no one writing this answer, which is good. Okay. So first of all, what is the problem at here? The problem at here is these words. Melting point is not a point. Melting point is not a point. Melting point is not a point. Okay. So melting point is it's not like a point on a graph. No. Melting point is a temperature. That's why you see, what is the melting point for the substance? 70 degrees Celsius. What is the melting point for this substance? 87 degrees Celsius. Degrees Celsius, what is it? Temperature. So melting point is a temperature. And you must add another one more words. Okay? So when you do melting process, when you melt a substance, the temperature didn't change. Example, if the melting point is 70, you heat the solid until 70, the temperature will stop at 70. Stop. It won't increase or decrease already. Stop there. It will stop at 70 until all the solid become liquid. Okay? So during the melting process, the temperature didn't change at all. So when temperature didn't change, you must add another one magical word in front. Constant. Okay? So melting point is a constant temperature where solid change to liquid. You still cannot get the full mark yet, okay? Because melting point is not only affected by temperature, melting point also affected by pressure. Okay, what do I mean? Example, today, if I say the melting point is 70 degrees Celsius now, if I bring this thing, if I bring the substance to the moon, for example, and I try to melt the substance, the melting point is not 70 already. It will change. Why? At moon or at other planet, the pressure is different. Different pressure will change the melting point. So what you need to do, melting point is a constant temperature where solid change to liquid at a specific pressure. You must say specific pressure or at a certain pressure. Okay, Mr. Martin, can we write atmospheric pressure? Cannot. Okay, in FBM, cannot. Must write specific pressure because not necessary is atmospheric pressure one. Sometimes we will change the pressure one. So specific pressure. Okay, so guys, let me know in the chat box, are you okay with what is melting point now? Are you okay with what is melting point now? So guys, you compare with your answer. Can you see that? Okay. It's something very easy, right? But not even a person can answer it correctly. Not even one. Okay. That's why I say answering technique is important. You need to know what should be written. Yeah. So melting point is a constant temperature where solid change to liquid at specific or particular pressure. You can say specific pressure, particular pressure, or certain pressure also can. Yeah. So that is how we answered it. Okay. So now same thing. If the question asks you what is boiling point, same thing. Boiling point is a constant temperature where liquid change to gas at specific pressure. Yeah. So that is how it works. Okay. So now we already know why we need to learn heating curve and cooling curve to find melting point, boiling point, freezing point, and condensation point. So how the shape of heating curve and cooling curve looks alike? Staircase. Staircase going up, heating curve. Staircase going down, cooling curve. Yeah, that's it. Okay, now you can only have maximum 2 staircases. Maximum only 2 staircases out there. Okay, so example, okay, you see, this is a, okay, all right, so you can see a stack, this is the staircase, right? Okay, so, okay, how to know how many staircases you have? Staircases, you go to see the horizontal line. You see how many horizontal line you have. You see 1 and 2 horizontal line. So you have 2 staircases. If they put another one here, 3 staircases, which is impossible. Maximum only 2 staircases. I will tell you why later. Same thing for cooling curve. Okay, maximum 2 staircases. Cannot be more. Yeah, maximum only 2 staircases. Cannot be more. Yeah, all right. So now, okay, I hope everyone understand. Okay, heating curve staircase go up, cooling curve staircase go down. How many staircases we have? Maximum 2. Okay, maximum is 2 lah. Okay, so now today we were only focusing on heating curve because if you try to learn heating curve and cooling curve in the same day, you will feel very confusing one, very blur one. If you try to learn heating curve and cooling curve right in the same day, super confusing. That's why today we only focusing on heating curve. That is good enough already for today. Okay, so first of all, I want you to know how to do the experiment. How to do the experiment in order to get the heating curve. Yeah. So to do the experiment for heating curve, this is how it looks like. Okay. So first of all, you take this. Yeah. First of all, you take a test tube. Okay? This is not a test tube. This one we call boiling tube. All right. So what is the differences between boiling tube and test tube? Okay. So some students say, sir, can I write test tube here? Cannot. What is the difference between boiling tube and test tube? There are 2 differences. Number 1, boiling tube normally is larger. Test tube normally is smaller. Number 2, boiling tube normally the glass is thicker. The glass is thicker. Test tube, normally the glass is thinner. That's why we call it boiling tube. This tube, you can heat it. You can heat the tube to boil it. So when you heat the tube, which means that this tube must able to withstand. We call tahan high temperature. So that's why boiling tube, the glass is thicker. Thicker glass can withstand higher temperature. So I hope everyone understand the differences between boiling tube and test tube. So now we are using boiling tube, not test tube. So inside the boiling tube, you put the substance that you want to heat. Let's say this is called solid X. Mr. Martin, if I don't put solid, can I put liquid? Can also, no problem. Okay, here you put a piece of thermometer. Why we need to put thermometer? Okay, guys, recall back. Heating curve, what is the graph? Heating curve, the graph is temperature and time. So we need to measure the temperature. Yeah, heating curve, we need to measure the temperature. That's why we use thermometer to measure the temperature. Yeah. Okay. Now, one thing here. When you do the heating curve, we use this kind of special thing. We put a water. So we take a beaker and then we put some water inside. Okay. So this one has a special name. You see, we take a beaker. This beaker inside put some water. You call this thing as water bath. You call it as water bath. Then you go to put the substance inside here. You put the substance, okay, inside here. And you go to heat the substance. You take the Bunsen burner here and go to heat the substance. Okay. So this type of heating is called indirect heating. Okay, first of all, we must understand the differences between direct heating and indirect heating. Okay, what is direct heating? Direct heating like this. Direct heating, this is your boiling tube. This is the substance you want to heat. This is a thermometer. If you directly take the Bunsen burner, put like this, you directly take the fire and burn it. This is called direct heating. So direct heating got one problem. Direct heating got one problem. Because if let's say the fire is heating here, which means that this area very hot, this area not so hot. You don't want. You don't want that one area very hot, one area not very hot. You don't want. You hope all the area they are equally hot. Okay. So when you do direct heating, there will be a problem. What is the problem? The problem is you will have uneven heating. Uneven heating. Uneven heating means the heating not balanced. Okay. So how to solve the problem? To solve the problem, we do this. This is called indirect heating. So when we do indirect heating, what happened, everyone? This is the Bunsen burner. Now the Bunsen burner not heat the substance directly. No. Now the Bunsen burner heat the water. When you heat the water, what happened? Now the water is hot. So now when you have hot water, the hot water then will go to heat the substance for you. So can you see? I don't heat the substance directly. Okay? I heat the water. Eventually, my water heat the substance. So this is called indirect heating. Okay, guys, let me know in the chat box. Are you okay with how to differentiate direct heating and indirect heating? Are you okay? Okay, good. So now you guys should know the differences between direct heating as well as indirect heating. Now come to a very important question. Why we prefer indirect heating? Why we love indirect heating? So in SPM, this is a very popular question. They will ask you, why we do the heating by using water bath? Why when we do the heating, we are using water bath? Water bath means indirect heating. So when you use water bath to do indirect heating, the reason is because you want to ensure uniform heating. Or you want to say, you also can say ensure even heating. You want the heating to be to be equal. You don't want one area more hot than another area. No, you want all the area equally hot. That's why you do direct heating. How to do direct heating? Using water bath. That's it. Okay. So this is a very, very popular question in the SPM paper. So make sure everyone know why we use water bath. Okay. Okay. Now there's a few things you need to know. When you put water bath, there's a skill, there's a skill. You see, when you want to use water bath, okay, let's say this is the water, guys. Let's say this is the water level. You must make sure that this substance that you want to heat, this whole thing, look at the brown color, look at here, look at this whole red color part. The whole red color part must be immersed into the water. You don't want a certain part of red color go into water. Why? Because only when the whole thing go into the water, later this whole thing can be heated by the hot water here and here and here and here. True or not? But if let's say only a small portion immersed in the water, let's say only here. So what happened? So only this part immersed in the water, so only here will be heated. And then this area not being heated. You don't want that. So you must make sure that the whole substance that you want to heat, they are fully immersed inside the water. Yeah. So that is why we need to do that. So that's why you say there's a lot of technical knowledge we need to know. Okay. I hope everyone know why the substance that you want to heat must be fully submerged under the water. Okay. Next one. Do we only can use water bath? No. Sometimes you can change the water here to become oil. We call oil bath. Same concept lah. What is oil bath? You heat the oil, then the oil is hot. The hot oil heat the substance. Still a indirect heating. Or sometimes it can be a sand bath. Okay? You heat the sand when the sand is very, very hot. Okay? So then the sand go to heat the substance. No problem. So it can be a water bath, it can be a oil bath, it can also be a sand bath. That's it. Now come to a golden question. When should we use water bath and when should we use oil bath and sand bath? Okay? Now, when we need to replace the water bath to oil bath and sand bath, when we need to change the water bath to oil bath and sand bath, when we want to heat the substance beyond 100 degrees Celsius. What do I mean? Let's say today I want to heat this substance to 170 degrees Celsius. Can I use water bath? Cannot. Because when you use water bath, water boil at 100. So when you heat until 100, not even 170, not yet. When you heat until 100, all the water here will start to boil. They become bubble. When the water boil, they will become gas. So the gas will run away. The gas will all run away to surrounding. So when the water boil, you will see the water become lesser, 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 and lesser. Sooner or later, all the water dry. The water dry already. And when the water dry, you're not even reaching 170 degrees Celsius yet. At 100, the water dry already. When water dry already, how are you going to continue with your experiment? So guys, let me know in the chat box, are you okay with why we cannot use water bath when the temperature more than 100? Are you okay with this? Can, because when the temperature is more than 100, the water will boil and the water will become gases. And when the water become gases, which means that the water bath will dry. Yeah, the water bath, they will dry. So that's why cannot lah. Okay, we cannot do that. Yeah, we cannot do that. Yeah, all right. Okay, so now let's look at the next thing. Okay, let's look at the next thing here. Okay, all right. So okay, so the next thing that we want to look around is this. Okay, so when you change to at 100 degrees Celsius or more, you change to oil bath or sand bath, no problem. Let's say I want to heat a substance to 170. I don't use the water bath now. I use some oil bath, no problem. Because for oil, normally for oil, their boiling point is more than 100. For oil, the boiling point normally quite high one, quite high one. Example, let's say I use coconut oil. Coconut oil, the boiling point 300 degrees Celsius. Okay, ma? You heat until 170, the coconut oil not boiling yet. When the coconut oil is not boiling, so you no need to worry lah. The oil will boil and become gases and the oil become lesser. No need to worry lah. So why we use oil bath? Because the temperature more than 100 degrees Celsius. Same thing. When you use sand bath, it's the same thing. When you use the sand bath, sand, the boiling, not even boiling point, sand, the melting point, sand is a solid ma. For the sand, the melting point, it will be around 3,000. So high. Okay, so no need to worry lah. At 3,000, only the sand will melt. Okay, not even boil. So no need to worry lah. Okay, so that's why the sand can be heated until a very, very high temperature. So no problem. So I hope everyone here understand how the diagram for heating curve looks alike. How the experiment for heating curve looks alike. The substance you want to heat, put a thermometer to measure temperature. Then you do indirect heating. Indirect heating means what? You take the entire boiling tube, and put it in the water bath. You put it in the water bath. Yeah. So that is what we need to do. Yeah, this is what we need to do. All right. So not very hard, but you really, really need to understand the logic behind lah. Yeah. What's the logic behind and why we are doing that? Yeah. All right. Okay. So finish already. Yeah. Okay. We're all done with this concept. Okay. So when should we use water bath? When the temperature you want to heat not over 100. Let's say I want to heat a substance to 70 degrees Celsius. No need to use oil bath. No need to use sand bath. Yeah. So, but when you want to heat a substance to the temperature more than 100, you must change the water bath to become oil bath or sand bath. That's it. Okay. Finish. Okay. Now I will start to teach you how to analyze the heating curve and how to analyze the cooling curve. How are we going to analyze the heating curve as well as the cooling curve? This is something very, very important. So let's do it together. Okay. So now, after this, we'll do a lot of exercises together. Hopefully, the exercises will give you a much better idea. Okay, so now we already okay, what we learned so far. Okay, we learned about heating curve as well as cooling curve. Heating curve and cooling curve, they are graph. Okay, so this graph, what we have over here, anyone remember what we have over here? What is this? What is the title here? Heating curve and cooling curve. What is the title over here? I say just now. What's the title on top here, everyone? Temperature. Very good. Heating curve and cooling curve must have temperature and time. Yeah. Temperature and time. Okay, so remember, heating curve and cooling curve, what is the shape, everyone? Staircase. Okay, heating curve, when you heat the substance, temperature go up, staircase going up. Cooling curve, when you're cooling down the substance, staircase going down. Okay, so how many staircase they can draw? One or two staircase. I don't want you to have a wrong concept that it must be two staircases. No, it can be one staircase or maximum two staircases. I say maximum is two. Maximum two doesn't mean it must be two. No, it can be one also. That's what you see. Okay, let's look at some question here. Okay, you see, let's say this question. All right. So everyone look at this picture. Heating curve or cooling curve? Heating curve. Why? Temperature go up. How many staircase we have, everyone? One. Only one staircase. You got it? So I don't want you to have a wrong concept to think heating curve must be two staircases. No, I say maximum two staircases. I didn't say that it must be two staircases. Understand? It can be one staircase. It also can be two staircases. So that's it, like this. This is a heating curve or cooling curve, everyone. Let me know. Heating or cooling curve from this picture. Heating or cooling curve, everyone? H or C? Heating or cooling curve? Heating, because the temperature go up. Okay, guys, how many staircase in this case? How many staircase in this question? How many staircase in this question? Two, because I told you how to see the staircases. Look at the horizontal line. horizontal line, horizontal line, two staircases. Understand? But I'm trying to tell you that heating curve can be one staircase, can also be two staircases. Yeah, not to say it must be one staircase. No, one or two staircases. Yeah. Okay, now I'll teach you how to analyze this heating curve and cooling curve. Okay, so now let us sketch the heating curve together. Okay, so how to do it? Imagine this. So first of all, this is a solid. I do indirect heating. Okay, I do indirect heating. Okay, in the water bath. Can be water bath, can be oil bath, can be sand bath. No problem one. No problem. Right? So now, so this thing can be water bath, can be oil bath, can be sand bath. Okay, so you heat here, then this whole thing become hot, then you go to heat the substance. So this is called indirect heating. Okay, all right. So now let us produce the heating curve together. So first and foremost, everyone, what will happen? This is temperature and this is time. So when we start doing the experiment, what is the temperature we're starting? Remember everyone, when we do any chemical experiment, we didn't start from 0, 1. We didn't start from 0, 1. We always start the experiment from room temperature. We always start the experiment from room temperature, just like the question we discussed early on today. When we want to do freezing, what is the starting temperature? 25. 25 degrees Celsius is always the starting the temperature. Understand? So room temperature 25, around here lah. That's why don't start here, guys. This is 0. Start somewhere here. So when you heat the substance, what happens? When you heat the substance, temperature will go up. Okay? When you heat the substance, it will become hot and hot. Temperature will go up. So the temperature will go up until you reaching your melting point. Once you reach your melting point, so you will see that the temperature will stop changing already. Okay, why? Because this is where the melting starts. You will start the melting process already. Then melting go on until here. This is where you finish the melting. Yeah. So that is how it works. Okay. So during the whole melting process, during the whole melting process, the temperature didn't change. During the melting process, the temperature didn't change. So they are constant. Okay. All right. Then after everything finished melting, okay, all the solid now fully melted already. Now you become liquid. So when everything become liquid, you continue to heat again. When you heat the liquid will start increase temperature again. Now the liquid will go up 70, 80, 90. Temperature keep going up until the liquid reaching the boiling point. Once you reach the boiling point, you start to see bubble. When boiling is happening, the temperature stop changing. Okay, so this point is where you start your boiling process, and this point is where you finish your boiling process. Okay, so after you finish boiling, then everything become gas. When you heat the gas, temperature go up again. Okay, that's it. So guys, now why we can have maximum 2 staircases only? Why they are maximum 2 staircases? Because when you start heating the substance, the first horizontal line is melting, right? This is where the melting happening. The second horizontal line is where the boiling is happening. See that? After melting and boiling, is there any other thing you can do? Cannot, ma. After boil, everything become gas already. You keep on heating the gas. Nothing else will happen. Nothing will happen already. Okay? Okay. Question asking sublimation. Okay, sublimation curve is not in our syllabus. It's not in our syllabus. It looks very complicated. Okay, it looks very complicated. Probably if I got time, I can show you guys next lesson. But that's why I keep telling you, sublimation and deposition is not in heating curve and cooling curve because they looks much more complicated. Okay, so now Everyone, let me know in the chat box. Do you understand why we can have maximum 2 staircases only? Do you understand now? Get it, huh? So why we can have 2 staircases? Because the staircase, this staircase, the horizontal line here is where you change the state. Okay, on the horizontal line, this is where you change the state. That's why you have melting, boiling, freezing, condensation all happen on the horizontal line. So you see, melting, boiling, freezing all happen at here one. They won't happen at this line. They won't happen at this line. They won't happen at this line. No, all the change of states always happen on the horizontal line only. Okay. So when you have 2 staircases, the first staircase is melting. Second staircase is boiling. And after boiling, nothing you can do. That's why it's impossible to have the third staircase. Okay, so when the question gives us 2 staircases, it's very easy. Because if the question gives us 2 staircases, we know the first staircase is a melting, the second staircase is boiling. We know that. But it will be a problem when the question only gives you one staircase. If the question only give you one staircase, you have to be careful. Okay, this is temperature, this is time. Okay, everyone, let's look at here. This is heating curve or cooling curve. Heating curve. How you know? Temperature go up, right? So this is a heating curve. So how many staircase they give you? One. So when you only have one staircase, you have to be careful. One staircase, this staircase may be representing a melting process. Maybe it representing a boiling process, because if they only give you one staircase, it can be a melting, it also can be a boiling. 2 staircases, very easy. Two staircases. First one must be melting. Second one must be boiling. So 2 staircases is very easy. The problem is always with one staircase. So when you only have one staircase, how on earth you know that it's melting or boiling? In this case, you must read the question carefully. Okay, what do I mean by read the question carefully? You must read the question to figure out what is the starting form. Starting form means what? Whether they start from a solid or whether they start with a liquid. Example. Example. Let's say the question sound like this. They say, Martin, this is a heating curve. This is a heating curve for solid X. So do you know what process is it? Yes, you're starting with solid. When I give you a solid and you heat the solid, melting, like, am I right? So not. When I give you a solid, I heat it, no way it will boil. It will melt. But today, if the question say, this is a heating curve for a liquid Z. So if I give you a liquid in the first place and you heat the liquid, when you heat liquid, will it melt? No, liquid already melted. It won't melt again. So when I give you liquid, you heat it, it should be boiling. Everyone let me know in the chat box, are you understand what I am talking about? Are you understand what I am talking about? I'm trying to tell you, when you have one staircase, you have to be careful, because the one staircase maybe is melting, maybe is boiling. How to know? Read the question. Okay, let's try to do a simple self-test question together. Let's do a simple. Let's see, is there any self-test here? Okay, no, there's no here. There's nothing. Okay, never mind. All right, never mind. Okay, we'll do it later. Okay, we try another one more thing. Okay, we try another one more thing. Then we try to do another one more question together. Okay, all right. So now, the next thing I want you to know how to analyze. So now I'll teach you how to analyze. Okay, how are we going to do the analysis of your heating curve? Okay, so let's do something like this. Okay, so imagine we have a 2 staircase heating curve. Imagine now we have a 2 staircase heating curve. This is temperature and this is time. Okay, this is called A, B, C, D, E, F. Okay, So now I make them into a few different regions, we call area. So we have A to B. A to B means here, this area. Then we have B to C. B to C means here. Then we have C to D, which is here. Then we have D to E, which is here. And then here we have E to F, which is here. Yeah. So now I would like to teach you all how to analyze. What we want to analyze now, we want to analyze the state of matter. So when I use the word state means what? Solid, liquid, or gas. So everyone, how to analyze? Let me teach you the logic I use to analyze here. Okay, first and foremost, put your eyes on here. So when you see two staircases, it'll be easy. Two staircase is very easy. Because when you have two staircases, you know the first staircase is melting. The second staircase here is boiling. Am I right? When you have two staircase, it's easy. Okay. And now, from point A to point B, does it melt? No. Melting happen at here. Point A to point B, not melting. So not melting happen at here. Here, not melting yet. So if you're not yet melting, who are you? Solid. Am I right or not? If you're not melting yet, you are solid. Okay, now let's look at B to C. Okay, B to C, you have to be careful. B to C, what is it? This is where you start melting, and this is where you finish melting. Okay? So now, from B to C, this whole thing, what happened here? At this area, from B go to C, the melting is ongoing. The melting is happening. Happening means what? Okay? Not finished yet. Okay? Ongoing. So when the melting is ongoing, what you have? So when the melting is ongoing, some of the solid not melted yet, but some of the solid already melted to become liquid. So you will have solid and liquid. Understand? So at this area, you always have solid and liquid. Okay? So because why? The melting is ongoing, it's happening. So they might ask you something, they will ask you, at here, what is the state you have? Solid and liquid. At here, what is the state you have? Solid and liquid. At here, what is the state you have? Solid and liquid. At here, what is the state you have? Solid and liquid. But once you're reaching here, this point, what is the state you have? Liquid only. Why? Because at this point, your melting finished already. Your melting fully completed. So no more solid. At this point, everything already become liquid. Yeah? Okay. So now let's go on. C to D. C to D is what? C to D is here. So C to D, is it melting? No, melting is here, ma. So now no melting. Is it boiling? No, boiling is here, ma. So C to D means what? Melting already finished, but boiling not started yet. So after you melted, who are you now? You should become a liquid. Is it okay? Now let's look at D to E. D to E is here, horizontal line. So remember, you must be careful on horizontal line. Horizontal line is where we change the states. Is where we change the states. So we know boiling is ongoing. So at this point, boiling started, then going on, going on, going on, going on, going on, going on, going on. At this point, boiling ends or finish. Okay? So if I ask you, at this point, what is the state you have? So once the boiling started, you will have some liquid and gas. Why? Because once the boiling started, some liquid not boiled yet, but some liquid already boiled and become gas. So you have liquid and gas. So at here, what you have? Liquid and gas. At here, what you have? Liquid and gas. Understand? So that's it. So once you're reaching here, the boiling ended. When boiling ended, everything become gas. Okay, now last one. The E to F. E to F is what? E to F is here. So at here, what happened? Is it boiling? No, boiling is here. E to F is already finished boiling. When everything already finished boiling, everything should now convert to gas. Okay? So that's why I want you all to see a simple logic here. When you are on the slanted line means the line going up like this or the line going down like this. You only see one state. One state means it's only solid, it's only liquid, or it's only gas, isn't it? You see, let's say A to B, slanted line. That's why it's only solid. C to D, slanted line. So it is liquid. E to F, slanted line. That's why it is gas. Understand? But whenever you have your horizontal line means this one. Okay? Horizontal line, the change of state is ongoing. So when the change of state is ongoing, melting, ongoing, boiling, ongoing, you will always have two states. You always have two states there. That's what you see. Here, melting is ongoing. When melting is ongoing, what you have? Solid and liquid. Here, boiling is ongoing. When boiling is ongoing, what you have? Liquid and gas. Let me know in the chat box. Are you okay with this concept? So remember, guys, when you are on the horizontal line, you always have two states. When you are on the slanted line like this, slanted line, you always have one state. Yeah. So not hard, but you have to be very, very careful with it. You have to be very, very careful with this. Okay. So we're done. Yeah. Okay. Now let's try one question together. Okay, guys. Let's try this. Diagram above shows the heating curve of teh tarik. Diagram above shows the heating curve of teh tarik. Okay, so guys, how many staircase we see here? One staircase. And I told you, one staircase can be melting, one staircase can be boiling. Can anyone tell me in the chat box, you think this process is melting or boiling? Type M or B. You think this process is a melting or it is a boiling? Let me know. Very good. It's boiling. Why? Because I told you all. Okay. When you have only one staircase, you must know you are starting from what? You're starting from a solid or you're starting from a liquid. So we know teh tarik. Teh tarik is liquid, right? Teh tarik is liquid. So when I give you a liquid and you heat the liquid, when you heat liquid, they boil. So you know already this is boiling. So from this graph, you know already this is boiling. So now I want you all to tell me T1, T2, T3, T4, T5. Just tell me T1 what we have is a solid, liquid, gas, or solid plus liquid, liquid plus gas, whatever. T1 what we have. T1 what we have at T1 here. At T1 what we have. Purely liquid. Am I right? Because slanted line should have only one state, and this is boiling, everyone. Here the boiling not started yet, not yet boiling. So when the boiling not started yet, not boiling yet, you are purely liquid. Okay, now T2. So T2 is here already. Okay, guys, T2, tell me what we have. T2 what we have? Liquid and gas. Am I right or not? Because T2 is already on the horizontal line. Remember, horizontal line. This is where the liquid start to boil, and this is where the liquid finish boiling. So T2 is here already starting to boil. When you start to boil, you have liquid and gas already. Okay, T3. T3, what is it? T3 is also on the horizontal line. When you are on the horizontal line, okay, what we have, T3, when you are on the horizontal line, liquid plus gas, right or not? Still liquid plus gas, still liquid plus gas, because still ongoing what? The whole process still ongoing, okay? Because you see, T3, do you finish boiling already? Not yet, The boil, you're in the middle, You're in the middle, not finished yet, finishing at here, Okay, guys, tell me T4. T4, what you will get? T4. Can you tell me T4, what you will get? T4. At T4, what you will get? Only gas, Only gas. Why? Because T4 already here, The boiling starting here, the boiling finish here, ma. So at T4, the boiling already finished. When the boiling already finished, all the liquid already boil. So when all the liquid fully boil, all become gas. So T5 easy lah. T5 is at here. This is boiling. This is after the boiling. After the boiling, everything is gas. Is it okay? So I hope all of you understand what is ongoing. I hope all of you understand what is happening. Not very hard one, okay? But you really need some good understanding lah, okay? Because if you only go by pure memorizing, you cannot survive one, okay? That's why I keep telling you all, chemistry is not a subject that memorizing everything one. No, you memorize everything, but you don't understand, no point. You understand the concept, but you don't know how to do the question, no point. Okay? That's why there's so many things we need to do. Learn theory first, understand the theory, and after that, we do many questions to enhance your answering techniques. Okay, that's it. Yeah. All right. So now let's do some exercises together. Can we do some exercises together? Let's try to do it. Okay. All right. Here we go. Okay. So the first question, okay, this question coming from Kelantan, 2023. Which of the following is a liquid at 100 degrees Celsius? They give you melting point, boiling point, 100 degrees Celsius. You know already. This one must use three lines method. Okay, must use three lines method lah. First one, melting point, -157, boiling point, -9. Solid, liquid, gas. Now I want 100 degrees Celsius. Where is 100? 100 more than 195, more than -157, 100 more than negative 9, so it's a gas. Okay, so this fella should be a gas. So let's look at substance Q lah. So substance Q, we have -13 and 55. So solid, liquid, and gas. Okay. So the temperature we wanted is 100. So where is 100? 100 more than -13, more than 55. Here, gas. All right. So the answer should be C. Okay. Why? So melting point given 80, boiling point given 196. Here, solid. Here, liquid. Here is gas. The temperature we're looking at is 100. Where is 100? 100 is more than 80, less than 196. Sorry, less than 196, correct? So in the middle, liquid lah. Okay, so liquid. So the answer is C. So I really hope that you know how to do it. So don't be lazy, guys. If you're not sure, draw the three lines. Some students, they just want to do shortcut, but they're not familiar at all. If you're not familiar, you're not sure, don't be lazy. Draw the three lines. Yeah, draw the three lines, please. Okay, next one. All right, this is a Terengganu paper. Okay, this is a Terengganu paper. So Terengganu paper here, they give you a heating curve, right? Or not? How I know this is heating curve? I saw staircase, and then this staircase is going up. When staircase is going up, is heating curve. Staircase going down is cooling curve. So can we know what is the state here? Melting or boiling? Tell me, everyone. Melt or boil? M or B? Melting or boiling, everyone? This is what? Melting or boiling? Melting, why? Solid, or not? Okay, that's why I told you, when you only have one staircase, you must read the question carefully so that you understand whether you started with a solid or you started with a liquid. Yeah, now in this question, we start with a solid. So it's a melting. So I know already this process is a melting process. So what they want? Okay, so they ask you what is the point X and what is the physical state. So what is point X? So when this is melting, point X is the temperature. Temperature where melting occur. What temperature melting occur? So X is melting point. Am I right? X is melting point. So melting point is the temperature where we have the melting process. So X should be your melting point. So what is the physical state of Z? So what is the physical state? R to S. So R to S, where is it? Okay, where is it? So this is melting, this is melting. So R to S is here. So R to S is in the middle. So when you are on the horizontal line, which means the melting is ongoing. So when the melting is ongoing, some solid not melted yet, some solid already melted become liquid. That's what I told you. On the horizontal line, you always have two states, solid and liquid. The answer is donkey. Yeah. I hope everyone know what is happening. I hope everyone know what is happening. It's not very hard actually. Yeah, it's not very hard actually. Yeah. Next one. So this is a question that a little bit to do with K, but this question needs some critical thinking. This question need you to think a little bit, critical thinking. Okay, they ask you, which of the following phases show the strongest force of attraction between naphthalene particle? Strongest force of attraction. So how to do this thing? How to do this question? Strongest force of attraction. Okay, so everyone, can we analyze this together? Okay, all right. Or maybe I let you try to do this question first. I let you have a 1 to 2 minutes to try, and let me know the answer in the chat box. You try first before before we discuss. Yeah, come, you try first. I let you try first. Yeah, just try. I see many answer A so far. Okay, any other answer? Come on. Okay, good. So let's see. Yeah. Okay. So the answer is A. Yeah. Okay. Why? What is the logic? How to know who has a strong force or weak force? Listen, listen carefully. Okay, we learned back in last week or last lesson. In lesson number 1, we learned what? Solid, liquid, and gas. True not? Solid, everything stick together. Liquid, something stick together. Not, okay? So gas, maybe they don't stick. They are far apart like this. Okay? For example, right? So now, how to know the force of attraction? Who is strong and who is weak? So when you see force, force means like this. Force of attraction means holding hand. Who holding hand tightly, very tight? Who holding hand very tight? You see who's sticking together the most of? This fella, everyone sticking together. You hold my hand, I hold your hand. Hold hand, hold hand, hold hand, hold hand. Everyone holding hand. So the force of attraction is very strong. So who has the weakest force of attraction? You see? Now this one, not many people holding hand. You see this one? Holding hand, holding hand, holding hand, holding hand, holding hand, holding hand. This one maybe not holding hand, not holding hand, not holding hand. Or maybe like this. Only got a few people holding hand, not much. So when you only got very little people holding hand, the force is weak. So liquid is in the middle, strong and weak in the middle, more the rate. So this is something we learned last week, isn't it? We learned last week. So everyone should know, solid, the force is very strong. Gas, the force is very weak. Liquid, the force is moderate. So in this case, they ask us, who has a strongest force? Actually, what is the hidden question? The hidden question actually is, who is solid? True not? Because when you are solid, the force is very strong. So how to know where is solid? So we learn. When you have two staircases, the first staircase is melting. Second staircase is boiling, isn't it? Okay, when we have two staircases, the first one is melting, the second one is boiling. So we know at here, melting not started yet, everything solid. At here, melting ongoing, solid and liquid. At here, melting finished already, everything liquid. At here, boiling is happening, boiling is ongoing, liquid and gas. At here, boiling completed already. Everything become gas. So who has a strongest force? Solid. Where is solid? Here, ma? P to Q. So the answer is A. Okay, guys, let me know in the chat box. Can you see how to solve this question? Are you okay with this? So it's not hard, but you really need to know the logic of this question. Okay, so when they say strongest force of attraction, actually they are referring to solid. So you need to know where you can get your solid. Okay, so we have a few more questions to go. Let us finish it. All right, next one. This is a f.k.a. This is another trial exam paper from f.k.a. They say this is a heating curve. This heating curve is solid Q. So how you know? When you're given a solid and you heat it, you know already this process is melting. And guys, you see, there are two staircases, ma. Two staircases, easy lo. First staircase is melting. Second staircase would be boiling. Am I right? First staircase melting. Second staircase is boiling. So now let's see what the question asks. Which of the statement is correct? Q is liquid at 258 degrees Celsius. Let's look at 258. 258 is here. 258 is right on the horizontal line, boiling. So when boiling is ongoing, when boiling is happening, you always have two states. You should have liquid and gas. But they say only got liquid or nonsense lah. Am I right? Q is a solid at T1. Let's look at T1. Where is T1? T1 is here. T1 is on the horizontal line. And we know this is where melting started. This is where the melting ended. So T1 is where you first started with melting. When melting started, you will have some solid and some solid will already become liquid. Understand? All right, melting already start, ma. So should be solid and liquid. They say solid only. Nonsense lah, cannot be lah. Q is liquid at T2. So look at T2. So T2 is where the melting process finish. So when melting process finish already, all the solid become liquid. So yes, you only have liquid now, nothing else. Okay, why the answer couldn't be donkey? Boiling point is 105. Look at 105. 105 is melting. Should be melting point, not boiling point. Okay, guys, let me know in the chat box, are you okay with how to solve this question? Are you okay with how I solve this question? Okay, not very, very hard. Okay, so we have two more questions to go. Let us finish it. Two more questions to go. Let us finish it. Okay, this is a MRSM trial exam paper. This is the MRSM trial exam paper in the year of 2022. So they show you a heating curve. This heating curve only got one staircase. One staircase maybe is melting, maybe is boiling. How to know? Read the question carefully. They say heating curve for solid, acetic acid. So you started with a solid, so it should be melting. Correct. When you given a solid, you heat it, it should be a melting process. So we know this is a melting. So which statement can be deduced from this particular diagram? What we can get from the diagram? No heat is absorbed in the first 2 minutes. Wrong. Heating curve always absorb the heat from beginning to end. From 0 all the way until 8 minutes. Heating curve always absorb the heat. That's why you see, guys, what is the picture or what is the diagram for the experiment for heating curve? Look at here. Heating curve, what do? You keep heating the whole thing, or not? You keep on heat the substance. When you heat the substance, all the heat energy go in, ma. When you heat the substance, all the heat will be absorbed. Okay. When you heat the substance become hot. Why? Because they absorb the heat. So by right, they should absorb the heat. But the question say they didn't. The question say no heat absorbed. Cannot be lah. Acetic acid need 8 minutes to melt. How to know how many minutes you need to melt? Look at here. Melting. This is where the melting started. This is where the melting ends. The melting start at minute number 2. The melting finish at minute number 6. 2 to 6, what happened? 6 minus 2. You need 4 minutes to melt everything. But the answer here say 8 minutes. Cannot be lah. Okay? Acetic acid undergo physical change from the 2nd minute to the 6th minute. So 2nd to 6th minute, here they say got physical change. Melting is a physical change because you change from solid to liquid already. You change from solid to liquid. So yes, it is. So this is a physical change. Yes, it is. So the answer is C. Okay, that's how it works. Okay, so let's do the last question for today. Yeah, so the last question for today is here. This is a Johor paper, 2022. Johor, 2022. So this is a heating curve for solid X. So heating curve for solid, you know already. When you heat a solid, this is a melting process. So they ask you what happened from 10 to 30. 10 to 30, here, melting. Okay, so melting is happening. Yeah, so not very hard. Yeah, so I hope you guys can get some rough idea how to do heating curve. Okay, cooling curve not yet. Okay, so that's it. So but we are not done with heating curve yet. Okay, so there's another small part for heating curve which I'll teach you in the next lesson. You see, today I only introduce you what is heating curve. The shape is a staircase. How to know where to get solid, solid and liquid, liquid, liquid and gas. That's what we learned today. Yeah. So next lesson, I'll teach you how to explain what happened on all these areas. Okay. What happened on all these areas. See, explanation, the answer will be a bit longer. Yeah. So this is what we will cover. Okay. And also in the next lesson, we will go through some what we say. Okay, we will go through some subjective question as well. Yeah, because so far today all the question is objective so in the next lesson we will do something like this. You see, subjective, 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 subjective. Yeah, we will do some subjective question for the next one. Okay, so I hope everyone learned something today. Yeah, so today our main concern is to understand what heating curve is all about. Okay, so I think that's all for today. I'll see you guys again in next lesson. Yeah.